Gears are one of the finest innovations that the humankind made in the power transmission sector. It has taken its role in almost all power transmitting systems. Before going into the details of specific sets of gear, we should understand how the concept of gear came into picture. In the earlier days, the power transmission was made possible using two cylinders which were rubbing against each other, something like this. But as the requirement of power increased, this system was not efficient, so they added some friction materials to the surface. But later, as the requirement of power increased, the humans added some projection to these surfaces, and later these projections are modified with some specific shape, something like this. You can see in the figure some specific shapes, and they called it as tooth. These tooth or teeth get engaged with another one and transmits the power efficiently. This is how the concept of gear came into picture. And in the later centuries, many additions has taken place in the gear, its construction and its power transmission features. All those things, day by day it is getting modified. Here in this session we will have a discussion about various type of gears and its applications. Especially we are focusing on the spur gear. So spur gears are generally used to transmit power between parallel shaft, and the teeth are also parallel to the axis. These are the most commonly used type of gear. Now comes the helical gear that also transmits power between parallel shaft, but the teeth are inclined at some particular angle which is called as the helix angle. It is less noisy compared to that of spur gear. This is because of the gradual engagement of this gear with the another one. Compared to the spur gear, the one teeth get meshed with the another ones all of a sudden, but that is not the case of a helical gear. Gradual engagement takes place. Because of that, the noise is less, and also it can transmit more power compared to that of spur gear, and also it can be used for higher speed applications. But if the shaft is inclined at some particular angle, we will adopt the bevel gears. We have got three different type of bevel gear. One is the acute angle bevel gear, second one is the right angle bevel gear which is shown in the figure, and another one is the obtuse angle bevel gear. Because if the shaft inclination is lesser than 90, it can be equal to 90 or it can be greater than 90. Like that, we have got acute angle bevel gears, obtuse angle bevel gears, and we have right angle bevel gears. So usually the bevel gear, the teeth of the bevel gears are straight, like in the figure it is very straight, but we can have some spiral type of gears. They are called as the spiral bevel gear. This spiral type of bevel gear helps into the gradual engagement and disengagement of the system, similar to that of the helical gear, and thereby it reduces the sound, and also it can transmit more amount of speed. So that is where we are going to use the bevel gears. And finally, the worm and worm wheel. There are also different type of other classification, but these are the main four classifications: worm and worm gear. Worm and worm gear consist of a worm, which is something like a thread, and we have a gear. I think in the figure it is very clear. You can see a thread which is running over a shaft, and we can have the gear here. This is called as the worm wheel, and this is called as the worm. So generally worm and worm gears are used when the power transmission ratio is greater than 10 or more, because we cannot have a single reduction using the spur gear. So if you want to have a single reduction, then obviously the only option we have is to go with the worm and worm gear, otherwise we have to go for the gearbox. So this is the general method of adopting the type of gear. And one important thing is that, most important thing is that in a worm and worm system, the rotation is transmitted from the worm to the worm gear, but not the opposite. That means power transmission is from worm to worm wheel or worm gear. The reverse is not done. So that is one of the main point when we discuss about the worm and worm gear. But in all other type of gears, the power transmission can be from any direction. There is no specific direction, but in a worm and worm gear, the transmission is from the worm to worm gear. That is the thing that you have to keep in your mind. Now we have to move into the design features of the gears, and one of the most common ratio that we have to discuss before going into the details of the design is the gear ratio. Gear ratio is nothing but d2 by d1. d2 implies the larger value, or the gear value, the diameter of the gear by diameter of the pinion. Pinion is nothing but the smaller among the two gears, that is called as the pinion, and the gear is the larger one. So d2 by d1, diameter of the gear by diameter of the pinion. Similarly, number of teeth of the gear divided by number of teeth of the pinion, and finally the speed of the pinion by speed of the gear, because the speed of the pinion will be higher compared to that of the gear. So the smaller one will be rotating at higher speeds. So this is a very common ratio we have to use when we go along with the design. d2, higher value divided by lower value. That is the easiest way we can remember this. d2 is higher than d1, z2 higher than z1, and n1 higher than n2. Now we have to discuss about the nomenclatures of a spur gear. It's a very important thing, because everything is specified in terms of different nomenclatures. So we know that pitch point is a point where two gear come into or meets. Two gear surfaces meet at the pitch point. So every tooth has a pitch point. This is a pitch line. So at this line, the two gears are coming into fully contact. So if you draw a circle joining all the pitch points of all tooth, we will get a pitch circle. I hope you all remember the concept of conjugate action, because the gear should meet at the pitch point. Then only it will have a constant contact ratio or constant speed. The speed of the driven and the driver should be same at this particular point. If it is not same, the meaning is that there is a slip happened between these two. So in order to have a constant velocity ratio, then the gear has to meet at the pitch point. That is what the law of gearing states. If you don't remember that, kindly refer to some textbook and read the concept of pitch point and pitch circle. Basically, pitch circle is an imaginary circle. You cannot find that in the gear. It's an imaginary circle. And we have the top surface. This is called as the top land. So the distance from the pitch circle to the top land is called as the addendum, and the distance below that is called as the dedendum. So the circle passing through the addendum is called as the addendum circle, and the circle which passes through the dedendum is called as the dedendum circle. we have fillet radius, we have clearance, we have working depth, and this particular length is called as the tooth thickness. And the distance between two successive points of a gear, not the straight line distance, the circular, the arc distance of two consecutive points of two teeth is called as the circular pitch. So this is the bottom land, the surface which is coming in contact with the teeth is called as the flank, this is called as the face. So these are the major nomenclatures that all of you should understand before going into the design. So this total length is called as the face width. That will also vary from gear to gear. Now we should understand what exactly is the module. Module is nothing but the ratio of diameter to number of teeth. So diameter of the pinion by number of teeth of the pinion, diameter of the gear divided by number of teeth of the gear. If two gears has to mesh properly, then both should have the same module. That is very, very important. If they are not having the same module, they cannot mesh properly. So they should have the same module. That is a very important thing. Now comes the pressure angle. What do you mean by pressure angle? See, when two gears are in contact, this is the point, pitch point. So at this pitch point, if you draw a normal to this curve, this is going to be the normal. And if you take the tangent of the pitch circles, this is one pitch circle, this is a second pitch circle. So if you draw a tangent to the pitch circle, and if you measure the angle between these two lines, the normal and the tangent, that is going to be the pressure angle. So usually the pressure angle is 14.5, and the details will be covered in the coming slides. So this is the pressure angle. Pressure angle is the distance or the angle measured between the tangent to the pitch circle and the normal to the pitch point, at the pitch point. So the size of the gear is purely based upon the module. As the module increases, the size will also increase, because as the module increase, obviously the diameter has to increase. So the size of the gear is purely depending upon the module. Now we should understand the standards, gear standards, because we cannot have an arbitrary number of teeth or arbitrary number of or size of the gear, because interchangeability is a very big issue we have to deal with. So if the gear has to be manufactured, it has to follow some standards. Usually the standards are being given by the International Organization for Standardization, ISO, for the metric sizes. The American Gear Manufacturers Association, AGMA, they are also giving some standards, and or the American National Standards Institute, ANSI, is all for inch size. These systems are followed for the fabrication of gears. So these standards specify modules, addendum, dedendum, tooth thickness, all those things, and the relationship between the other parameters or the other nomenclatures or the parameters. So usually we have some standard choices, because these standard organizations has given some standard modules under which we are supposed to manufacture the gear. So like given in this table, we can see different type of modules. We are supposed to go along with these standard modules. You cannot have a module of 42. It should be either 40 or it should be 50. You cannot have a module 9. Either it should be 8 or 10. So whenever we go for a design, we have to select a module which is specified by these organizations or the standards. Then only it can have the feature of interchangeability. If you want to have a proper mating of the gear, definitely both should be of the same module. So if you want to replace one gear which is having a module 2, then you have to get another gear which is having the same module 2. So that is the reason why we adopt or stick on to some standards. Similarly, we have got standards for the diameter pitch, and we have different gear systems also. What exactly do you mean by gear systems? See, tooth systems are mainly of two types. One is the full depth type and second one is the stub type. Full depth means the normal type of gear that we design, but stub is something different. Stub is something like reducing the total depth of the gear. So the total depth of the gear is reduced compared to that of the full depth. Thereby this stub teeth can take more amount of load and lesser deflection, something like that. So for higher power transmission, stub are being suggested, but usually we can go for the full depth or even stub. The general pressure angles, I hope you all remember what the meaning of pressure angles. In the earlier days we used the 14.5 degree pressure angle, but presently we adopt 20, 22.5, 25, 20, etc. in the stub. And usually all the dimensions of the gear are based upon the module. See, if you look at the 20 degree pressure angle full depth system, the addendum value is nothing but 1 m. M means module. That means if the module is 5 mm, then addendum is nothing but 5 mm. Like that, if every dimension of a gear is purely based upon the gear, module of the gear. So module plays one of the important role while designing a gear, because every dimension is specified, or the gear standard in gear standards, everything is based upon the module, the dimensions. So like the stub, if you look at the stub, you can see that the addendum value is 0.8 divided by PD. So compared to the full depth system, we can see the value of addendum, it is somewhat lesser than the addendum. Here it is 1 m, but here it is 0.8 m. So the total height of the depth of the teeth got stubbed, reduced. That is what is the meaning of stub systems. We can have subsystems in stub in 14.5, 20, 25, everything, but usually the teeth gear system, it will be specified in the question. Now, before we design a gear, we should understand how the analysis is being done, or how the gear system is, what are the forces acting on a gear system. For that, we will be using the Lewis bending stress. Now, Lewis bending stress, the teeth of the gear is considered as a cantilever. If you consider this particular gear, we can see that the load is acting somewhere here. So the projection can be considered as a cantilever beam with an end load, something like that. So this is how the force acts through the pressure angle line. I hope you all, once again we will go back. See, at this point the force will be acting. This is the line of action of the force. Like this, the force is going to act. The same thing is specified here, this one. This is how the force is going to act. So it has got two components. One is the tangential component and second one is the radial component. We have to understand the functions of these two forces. The radial component is the one which is going to keep the gear intact. The radial component is the one which is going to, or which helps the gear to keep in contact. And Ft is nothing but the tangential force is the one which is going to transmit the torque or the power. So both of these two forces are very significant when we design. Mostly our entire design will be based on the power transmission. So we will be fully focusing on FT. FT is a very important force. It is a component of force which is transmitting the power. So in a Lewis bending stress, a cantilever beam is assumed at the place of a teeth, and the forces are considered, and using the moment equation, m by I is equal to sigma by y. M is the maximum bending moment, I is the moment of inertia, and y is the distance from the neutral axis. So using this moment equation, the Lewis equation is built. This is the very fundamental of the Lewis bending stress. So when Lewis constructed developed the bending stress equation, he has selected various features of the gears, various correction factors were added to it, and finally this equation got modified. So other than the Lewis bending stress, because this is one of the major evaluation criteria of the gear, so while designing a gear we have to go through this Lewis bending stress. And the second one is the dynamic load. Dynamic load is developed in a gear due to the error, can be due to the error in the tooth spacing. If there is an error, because we are machining the system, the teeth, so some fabrication error can happen. So some due to the error in the tooth spacing, or if suppose the surfaces of the tooth surface are not perfectly parallel to the axis, or the inaccuracy of the tooth profile, or if the load is not properly distributed over the teeth, or it can happen due to the deflection of teeth under load, or it can happen due to deflection of the shaft and mounting. So these are various factors. That can be considered when we look into the dynamic load, because all these factors will contribute to the development of some kind of dynamic forces in the system. So these dynamic forces also has to be accounted when we design a gear. So dynamic load consists of two forces. One is a tangential load, and second one is the forces due to the irregularities. And the irregularities we have already discussed. These are the irregularities that causes or that results in the dynamic load, though this load also has to be considered while designing the gear. And finally the wear load. See, wear load in a gear failure can happen due to the breakage of the teeth due to the static or dynamic load. We have static load as well as we have dynamic load, and also it can happen, the failure can happen due to the surface destruction. See, all these happens just because of any of these four reasons. It can be due to the abrasive wear, due to the presence of some foreign particles which comes into the in between the gear tooth through the lubrication or through the contaminated atmosphere, anything like that. Or if it is working in a corrosive medium, corrosive wear can happen on the tooth, and thereby the tooth will fail. And the pitting can also happen because of the repeated loading, because the gear may not be working under constant loads, so fluctuating load will be there. So based upon the fluctuating loading, pitting can also happen. The scoring can also happen due to the metal to metal contact, due to the lack of lubrication. So these are some of the major reasons, some major 4 reasons for the wear to happen in a gear, and because of this there can be a failure. So in order to reduce the wear on the gear, it has to be surface treated. So that is also one of the important parameters we have to consider, because the surface hardness is a very deciding parameter when we talk about the wear. So surface hardness also need to be considered while we designing the tooth based upon the wear load. So like we said, the static load, Lewis allow bending stress, the second one the dynamic load, and third one is the wear load. These three are the major type of load which has to be considered or which is used for the design of a gear. So the purely the design is based on these three type of loads. So this is the very fundamental introduction to the gear. So after this we will go to the design procedure. There I will explain all the details of the design, because lot many factors has to be considered while designing the gear. Lot of correction factors, lot of tables, lot of standards has to be considered while we designing a gear. So that will be explained in the Spur gear design procedure.